Hello again. This is section 1.3, algebraic expressions. So in this section, we're going to look at what an algebraic expression is and then how we can actually simplify certain algebraic expressions. So the first thing we're going to look at are what's called polynomials. So a polynomial with a variable of x in the expression right here. So don't get too bogged down in the notation that's written here. Basically just understand that all of these a values, the a sub n minus 1, and so on, those are coefficients. So those are going to be numerical values. The x itself is your variable, and then the n values and the n minus 1 and so on, those are going to be your exponents. So when we actually write these things, there's going to be numbers in place of most of these variables. The only variable that actually remains is the x. Okay, so again, all the a values are real numbers. Those are called coefficients. The n values have to be non-negative, meaning they have to either be 0 or positive. And if a sub n is not equal to 0, then we have the degree of n in this case. So we have the n being the highest exponent of all the exponents in your polynomial, and so we would call that the degree. Now, each of these things that make up the polynomial that are separated with addition or subtraction, those are what we call terms of a polynomial. So we can look at the number of terms to determine what type of polynomial we actually have. Okay, so here's a few different types of polynomials. So the first one here, notice there are 3 terms because we have the 2x squared, the negative 3x, and the positive 4. This is a trinomial. So whenever there's 3 terms, we call that a trinomial. If there are 2 terms, then we would say it's a binomial. So x to the 8th plus 5x, those are 2 terms. Okay, so this is going to be a binomial. Once we get above 3 terms, we don't really have special names for those, so we would just say the next one is a 4-term polynomial. Again, those terms would be positive 3, negative x, positive x squared, and negative 1/2 x cubed. And then we have another binomial, 5x plus 1. And then the last 2 here are actually what we call monomials. So there's only a single term, no addition or subtraction, but they are still considered polynomials, even though they only have a single term. So 9x to the 5th would be the only term there, and then the last one would just be 6. Now notice with the last one, there is no variable, so there's no x at all. The degree of that monomial is actually 0 in that case. So whenever you don't have an x value, no variable, we would say the degree there is just 0. All right, so example 1, we want to find the sum of these 2 polynomials. So basically what we're allowed to do when we're adding or subtracting is we can only combine like terms. And what we mean by that is we can only combine things that have the same variable and the same exponent. So in this case, if I look at my first 2 terms in each set here, I have an x cubed. And since I'm adding these together, I'm going to add the 2 x cubes together, and that's going to give me 2x cubed. So you keep the like term itself, which is x cubed, and because we have 1 in the first set and 1 in the second set, when we add those together, we get 2 of those. All right, now I'm looking at my next term. I have a negative 6x squared, and then we have a positive 5x squared. So when I add those together now, negative 6 plus 5 is negative 1, so I end up with a negative 1x squared. And notice in this case, we don't actually need the coefficient of 1. There's an understood 1 in front of that x squared. All right, and then we have our 2x right here, and we have a negative 7x down here. So when I add those together, 2 plus negative 7 is negative 5. So we get negative 5x. And then finally, we have this plus 4. Notice there's no constant terms that I can combine with that 4. So this is just going to stay plus 4 now. And then always look to make sure you don't have any other like terms that can be combined. In this case, this polynomial is our answer because there's nothing else that can be simplified. All right, now the next one, same polynomials, but notice this time we're subtracting. So we have to be careful and make sure we're actually subtracting our like terms this time. So again, I'm going to start with my x cubed. I'm going to subtract x cubed. In this case, 1x cubed minus 1x cubed just becomes 0. So those terms just go away altogether. So now I'm going to look at my negative 6x squared and my positive 5x squared. When I add those, or sorry, subtract those, negative 6 minus 5 is going to give us a negative 11x squared. Okay, so again, just make sure you're paying attention here that we're subtracting. So negative 6 minus 5 is negative 11. Then I'm going to look at my next term. We have a 2x. We have a negative 7x. Again, we're subtracting though. And remember, whenever you're subtracting a negative value, it actually turns into addition. So we have 2x plus 7x. And so that's going to become a positive 9x. And then we still have our plus 4 here, nothing to combine that with, so it actually just stays plus 4 again. Again, always look to make sure you have nothing else that'll simplify. There are no like terms remaining in this polynomial, so negative 11x squared plus 9x plus 4 is our final answer. All right, now multiplication. So if we have two binomials, so remember binomial means two terms, so 2x plus 1 and 3x minus 5, we can actually use the FOIL method to multiply these together. So remember, FOIL stands for first, outer, inner, and last. Okay, so if we start with our first terms, that's going to be the 2x and the 3x. So we're going to multiply those first terms together. Well, 2x times 3x, 2 times 3 is 6, and x times x is going to give us x squared. Because remember our rules for exponents, when we multiply, we add the exponents. We have an x to the first, an x to the first, that gives us x to the second. Now we're going to do our outer terms. Well, the outer terms this time are the 2x and this negative 5. Well, if I multiply 2 times negative 5, that's negative 10. And then I'm just going to keep the x from the 2x, so we get a negative 10x. Now we go to our inner terms. The inner terms are positive 1 and positive 3x. So 1 times 3x is going to give us a positive 3x. And then finally we have our last terms. So that's going to be positive 1 times negative 5, and that will give us negative 5. And like I told you before, always look to see if there's anything that can be simplified or combined. In this case, we have some like terms, the negative 10x and the positive 3x, so we need to make sure we combine those. So we're going to have 6x squared. Negative 10 plus 3 should give us a negative 7x, and then we have our minus 5. And so our final answer for this one is going to be this trinomial right here. And just remember, FOIL is just an example of distributive property. We're really just distributing the 2x to both terms in the second set of parentheses, and then distributing the 1 to both terms in the second set of parentheses also. All right, now we have a binomial times a trinomial. Now, again, we're going to use distributive property to multiply this, but we do have something called the box method to help us organize our terms and make sure that we've actually multiplied everything that we need to. Okay, so you don't have to use this every time if you don't want to, if you're just comfortable using distributive property. Okay, but I'm going to set up a box here. And so my first set of parentheses has two terms. So I'm going to create two rows here, and I'm going to put positive 2x for the first row and positive 3 for the second row. Now my other set of parentheses is a trinomial, so I need 3 columns here. So I'm going to create 3 columns. And again, I'm going to list out my terms. So I have an x squared, I have a negative 5x, and then we have a positive 4. Now, to fill in each one of these boxes that I've created, I just have to multiply the row by the column. So in this case, I have a 2x and an x squared. So if I multiply those together now, that should give us 2x to the third power, because again, we're multiplying, which means we're going to add the exponents. Now I'm going to go to the next box to the right. So now my row is 2x, my column is negative 5x. If I multiply those together, 2 times negative 5 is negative 10, and x times x is x squared. Now I'm going to look at the last column, first row. So we have 2x and 4, so that's going to give us a positive 8x. Now we can move down to the second row. So I'm multiplying the 3 times the x squared. That's going to give us 3x squared. Then we're going to have 3 times negative 5x. That should be negative 15x. And finally, 3 times 4 is going to give us 12. Now, once we've made sure that we've multiplied everything together that we're supposed to, now we can start to combine like terms. So notice here, we have x squared terms here and here, and we have x terms here and here. So if I combine those, I'm going to keep the 2x cubed, nothing to combine that with. Negative 10x squared and positive 3x squared should give us negative 7x squared. Then we have a positive 8x and a negative 15x. Combining those should give us a negative 7x. And then finally we have the plus 12 that doesn't combine with anything. And so this right here would be our final answer. Now, again, all we're really doing there is multiplying 2x times all three terms in the second set of parentheses, and then multiplying 3 by all three terms in the second set of parentheses. So if you can do that without the box, that's perfectly fine. If the box helps you to organize your work, that's perfectly fine too. All right, now some special product formulas. So if we have a plus b times a minus b, that's going to give us what we call a difference of squares. So the a times the a gives us a squared. The b times the negative b gives us negative b squared. And your outer terms and inner terms in this case will actually be opposites of each other. And so those terms just go away. So we have a negative ab and a positive ab. And that's why we have no middle term this time. Now with a plus b quantity squared, remember when you square something, you're actually multiplying that value by itself. So really what a plus b squared means is a plus b times a plus b. And if we use FOIL here, that's going to give us a squared plus our outer terms give us ab, inner terms give us another ab, and the last term should give us b squared. And when we combine like terms, we have a squared plus 2ab plus b squared. So that's how they get that result, a squared plus 2ab plus b squared. And you can do similar work for the next one. It's just a minus b times a minus b. If you use FOIL, combine your like terms, you should get a squared minus 2ab plus b squared. And then the last one here, the last two, a plus b to the third power and a minus b to the third power. Now we're multiplying a plus b times itself 3 times. You would have to do your distributive property on the first two, and then whatever you get there, you would multiply by the last one. But just know that if you do something like that, you're going to get something of this form, a cubed plus 3a squared b plus 3ab squared plus b cubed. And if there's subtraction instead, the terms look very similar. The only difference now is the second and last terms are going to be negative instead. All right, so let's use those special product formulas here to find each of these products. So we've got 3x plus 5 all squared. So the first thing I'm going to do here is I'm going to identify the a value and the b value so that I can use those formulas that we just looked at. So remember, this first term right here is going to represent the a value, and then this term right here is going to represent the b value. And notice we're adding, so this is an a plus b quantity squared formula that we're using. So if we look back at our notes, that said that we're going to have a squared plus 2ab plus b squared. And so now substituting into that formula, this is going to give us 3x all squared plus 2 times the a value, which is 3x, times the b value, which is 5, plus the b value squared, which is just 5 squared. Now we can simplify that. So 3x quantity squared, we're going to square the 3 and square the x. So that's going to give us 9x squared. Multiplying all three of these together now, 2 times 3x times 5, that should give us plus 30x. And then finally, 5 squared should give us 25. And as always, look to make sure you don't have any like terms to combine. In this case, there aren't any, so that is completely simplified. So that is our answer. All right, so then if we look at the next one, again, I'm going to identify the a value and the b value. So this is a minus b quantity cubed. And so if we look back at our formula here, that should be a to the third power minus 3a squared b plus 3ab squared, and then minus b cubed. And so again, I'm going to substitute these values in there. So I'm taking my a value and I'm raising it to the third power. Well, my a value is x squared this time, so that gets raised to the third power. Then we have minus 3 times the a value squared, so that's x squared squared. We're going to multiply that by the b value, which in this case is just a 2, plus, and then we have 3 times the a value, which is x squared. Then we multiply that by the b value squared, so that's 2 squared. And then finally, we're cubing the b value, which is just going to be 2 to the third power. Notice here, because I'm using the formula that has subtraction in it, I don't need to keep the negative sign with the 2. I'm just thinking of the 2 as a positive value now. Okay, so the subtraction's taken care of with the formula itself and the fact that we have those minuses in the formula. So now we're just going to simplify this. So x squared raised to the third. Remember, when we raise a power to a power, we multiply. So that's going to give us x to the 6th power. Then right here, we have a negative 3 times 2 is going to be negative 6. We're raising a power to a power, so that's going to give us x to the 4th power. Down here now, we have 3 times 2 squared. 2 squared is 4, times 3 should give us a 12, so we get plus 12x squared. And then finally, we just need to raise 2 to the 3rd power. That's going to give us 8, so we get minus 8. Again, look for any like terms. We don't have any this time, and so this right here should be our final answer. Now, again, if you wanted to do this by hand and just take the x squared minus 2, multiply it by itself 3 times, simplify everything, you're going to get exactly the same answer. Okay, so the formulas are a shortcut. Okay, it does definitely shorten that process. There's fewer steps. Okay, but if you ever do forget the formulas, you can always just manually go through and multiply x squared minus 2 times x squared minus 2 times x squared minus 2, and you should get the same answer. All right, so now we want to find each of these products. So we have 2x minus the square root of y times 2x plus the square root of y. So again, this technically fits one of those formulas that we just saw. Okay, I'm still just going to go ahead and use FOIL on this one because I think this is probably just as easy to do that way as it is to try to use the formula with a's and b's. So I'm going to do 2x times 2x. That's going to give us 4x squared. My outer terms now, we have 2x times the square root of y, and it's positive, so positive 2x square root of y. Then we're going to multiply our inner terms. That's going to give us a negative 2x times the square root of y. And then finally, we have a negative square root of y times a positive square root of y. When you multiply those together, you actually get the square root of y squared, which just gives us y. Okay, and again, when we multiply a negative times a positive, it should come out negative. So this is just going to be minus y. Now again, we always look for like terms. Notice here we have a positive 2x times the square root of y. We have a negative 2x times the square root of y. Those are actually going to cancel each other out now. Okay, so that gives us 0 in the middle. So all that's left is 4x squared and a minus y. Okay. And again, that's one of those difference of squares that we looked at before in the formulas. So if you want to use the a minus b times a plus b formula and do it that way, that's perfectly fine. But I think in this case, it's probably just as easy just to use FOIL and then combine like terms. All right, now the next one, there are technically 2 trinomials here, right? We have x plus y minus 1, 3 terms, and then x plus y plus 1, another 3 terms. You could do the box method, right? And you could set up 3 rows and 3 columns, multiply everything together, get your answer that way. But if you notice here, we actually have this x plus y that's the same for both sets of parentheses here. And so really what we can do is think of this as a difference of squares now, where we're multiplying x plus y times x plus y to give us x plus y squared. Then when we do our outer term here, that's going to give us plus x plus y. The inner term here is going to give us minus x plus y. And then finally, the last term's -1 times 1 is going to give us a -1. Now, because we have an x plus y minus an x plus y, these actually cancel each other out now. And so I really just have x plus y squared minus 1. Now, we could go a step further and actually expand out the x plus y quantity squared now. Remember, using that formula, I'm just going to take the x value and square it. Then I'm going to add 2xy. Then we have plus y squared. And then we just have to bring down the -1 that we had in the previous step. Again, look for any like terms. In this case, we don't have any. And so this would be our answer right here. But again, if you actually just set up your table and you did x plus y -1 is 3 rows, and then x positive y positive 1 is your 3 columns, and you multiply it and combine like terms, you get exactly the same answer that we got here. All right, now we're going to look at factoring. Okay, so far everything we've done has just been multiplying. So now we're actually going to start to work backwards and think about how we can factor some of these expressions. And what we mean by that is we're looking for things that they have in common that we can actually bring out. So if we look at this first one, we have a 3x squared and we have a -6x. So my first step, I'm going to just look at the coefficients and see what numerical factor they have in common. Well, between 3 and -6, there is a common factor of 3 because 3 goes into both of those numbers. So I'm going to factor out a 3. Now I'm going to look at the variable. I have an x squared in my first term, and I have an x to the first power in my second term. We always want to take out the smallest exponent of all of the exponents that you have here. So in this case, x to the first power is the smallest. That's what they have in common. So we're going to take out an x. Now we have to figure out what would be left over if I factor out a 3x. We're basically dividing it out of what we started with. So I'm going to start with my 3x squared, and I'm going to divide out the 3x to see what's left over. Well, 3 divided by 3 is 1. X squared divided by x, remember we would subtract the exponents. So this is just going to give us a 1x or just an x. So now I know this term right here is going to be x. Now we can do the same thing with the -6x. I'm going to take -6x. I'm factoring out a 3x, so I'm going to divide it. -6 divided by 3 is going to give us a -2. And then the x divided by x is just 1, so the x's cancel out. And so we're just left with a -2. And so I get a -2 here. Now, you can always look to make sure there are no other common factors that can be factored out. In this case, the 3x on the outside, the x minus 2 on the inside, no more common factors. That is our answer. To check this answer, we can distribute the 3x and make sure that it gives us what we started with. So we take the 3x times the x, that gives us our 3x squared. And then if we distribute the 3x to the -2, that gives us the -6x that we started with. So this right here checks out. This is our factored form. So the next one now, we actually have 3 terms, but we're still doing the same thing. We're looking for any common factors that we can bring out. So I'm going to start again with my numbers. We have an 8, a 6, and a -2. Of those numbers, the only thing they have in common is 2. So I'm going to take out a 2. Now I'm going to look at the x part. Okay, I have an x to the 4th, I have an x to the 3rd, and I have an x. Remember, we're always going to take out the smallest exponent. So in this case, that's x to the 1st. So I'm going to take out an x. Now I'm looking at the y part. We have a y squared, a y cubed, and a y to the 4th. Again, I'm going to take out the smallest exponent, so that is y squared. Now we have to figure out what's left over. So again, I'm going to go term by term, and I'm basically dividing out the 2xy squared, and that's what's going to tell me what's left over. Well, if I take 8x to the fourth, y to the second, and I divide it by 2xy squared, 8 divided by 2 should leave us with a 4. X to the fourth divided by x, remember we would subtract those exponents. 4 minus 1 is 3, so we get x to the third. And then y squared divided by y squared, those actually just cancel out and give us 1, and so we're just left with a 4x cubed for that first term. Now I'm going to go to my next term. We have our plus. 6 divided by 2, that's going to give us a 3 as our coefficient. X cubed divided by x, again we subtract exponents. 3 minus 1 is 2, so we get x to the second power. Then we have y cubed divided by y squared. Again, subtract exponents. 3 minus 2 is 1, so we end up with y to the first. But again, we can just write y there. There's an understood 1 as the exponent. And then finally, the last term, we have a negative 2 divided by 2. That's going to give us a negative 1. X divided by x is just 1, so we don't really need that. And then y to the fourth divided by y squared. If we subtract those exponents, that's going to give us y squared. And again, notice I didn't have to put the 1 in front, even though 2 divided by 2 gave us 1. The 1 there is understood, so we only need the minus y squared. Now again, you can check your answer by distributing back out the 2xy squared. If we do that, 2 times 4 is 8, x times x cubed is x to the fourth, and then we have our y squared. That looks good for the first term. Second term, 2 times 3 is 6, x times x squared is x cubed, y squared times y is y cubed. Second term checks out. And then if we do the last term, 2 times negative 1 is negative 2, x times nothing, right, or in this case 1, is going to give us the x. And then y squared times y squared is going to give us y to the fourth. Okay, so all those terms look good. So this right here is our factored form. And again, if you look at all the terms inside the parentheses, they don't have anything in common in terms of their numbers or their variables. Okay, and so we have to say that that is completely factored now. All right, now the next one. In this case, we actually have a common factor that is multiple terms. So if we look right here, we have an x minus 3, and we have an x minus 3 right here. So our common factor that we can bring out is actually that binomial x minus 3. So we're going to have x minus 3. And now we just have to figure out what's left over if we take that out. Well, if I divide this first product, the 2x plus 4 times x minus 3, if I divide out the x minus 3, all that's left is 2x plus 4. So I'm going to have 2x plus 4 left over here. And then if I look at this last piece, the 5 times x minus 3, if I divide out the x minus 3, all that's left is a minus 5. And so I'm going to get a minus 5 here. Now for this one, we can actually combine some like terms. We have a positive 4 and a negative 5. So this actually gives us x minus 3 times 2x minus 1. Okay. That is completely factored. There are no other common factors, no other like terms we can combine. And so this is our answer right here now. So just understand that anytime you have anything that's the same within a product, it is a common factor and it can be factored out. So even though this is x minus 3, it's a binomial, because it's the same in both terms, we can actually bring that to the front now. All right, now factoring trinomials. So I'm going to do this by what we call trial and error. So basically, I'm going to try some things. I'm going to work them out, see if it actually gives us what we started with. If it doesn't, then I'll go back and try something different. Okay. I know there's a lot of other methods, and if you have methods that work for you, by all means, please use them. I just think because so many people have learned so many different ways, it's hard to teach them all. And I think people often forget some of those methods along the way. And so trial and error is a tried and true method that always works. Okay, so we're going to go with that. Basically, what we're going to do here is anytime you have a trinomial, we're going to try to factor it into two separate binomials. So I'm going to want two terms in each set of parentheses this time. Now, the first thing I'm going to look at is this first term right here. And I'm going to ask myself, what could I multiply together to give me x squared? Well, in this case, x times x is really the only option because x squared times 1 is not going to help us. Okay, so we're going to say x times x is x squared. And because the coefficient is 1, that's really the only option that's going to give us x squared. So I'm going to start over here now and say, well, I'm going to put an x in this first set of parentheses, and I'm going to put an x in this set of parentheses, so that when I go back and do my FOIL, I get x times x, and that gives us the x squared that we started with. Now, the next thing I'm going to look at is our last term. So I'm looking now to think, what values could I multiply together that would give us 12? Well, there are several options here. Okay, so I could do 12 times 1. I could do 6 times 2. And I could also do 4 times 3. Now again, this is trial and error. So we could try any one of those 3 options, substitute those values in there, multiply it out, and see if it gives us what we started with. In this case, though, if we look at the middle term, we know we want to end up with a 7x in the middle. So once I combine like terms, I know that's what I need. Well, if I have a 12 and a 1, when I do FOIL, it's going to give me a 12x and a 1x. That's not going to work out to give me 7x in the middle. If you look at the 6 and the 2, same thing. I'm going to get a 6x and a 2x from my outer and inner terms. That's not going to give us 7x in the middle. The only option here that will give us 7x is the 4 and the 3. And it does not matter where they go. You could switch them up and put the 3 first and the 4 second. Okay, so long as you have those as your 2 factors. Now, the last thing we have to figure out are the signs that are going to go in each set of parentheses. Well, I know I need to end up with a positive 12. So my only options there would be to multiply a positive value times a positive value, or we could multiply a negative value times a negative value. In either case, we'd get a positive 12. But because I want a positive 7x, that tells me that I need both of these values to be positive so that when I add them together, it gives me positive 7x. So that means that this needs to be a plus and this needs to be a plus. Now, that is the answer. But again, we can check ourselves by actually distributing or using FOIL here to make sure we get the trinomial that we started with. So if I do FOIL, we have x times x. That's going to give us x squared. Then we do our outer terms. X times 3 is going to be a positive 3x. Inner terms, 4 times x, positive 4x. And then finally, we have 4 times 3. That's going to give us 12. Always look for like terms. We have a 3x and a 4x in the middle here. Adding those together gives us x squared plus 7x plus 12. That is the same thing that we started with. And so this right here is the correct factored form for that trinomial. And again, if you're unsure, right, and you say, well, I really don't know of those 3 options, the 12 times 1, the 6 times 2, the 4 times 3, which one do I want to use? You can actually just try one, right? Then FOIL it, combine your like terms, and if it doesn't give you what you started with, choose a different option, okay? Now, one thing I will suggest is if you're doing that, keep track of your trials, okay? So it's really easy to just erase things and start all over. And what I find is students end up repeating some of the same options that they've already tried. So if you find one that doesn't work, keep it on your paper, cross it out, and then try something else so that you can make sure that you're not repeating some of the same options. All right, so now we've got 6x squared plus 7x minus 5. Again, we're trying to factor this by trial and error. So again, we're going to start with 2 binomials. Okay, so I'm going to do my 2 sets of parentheses here. Again, first step, I'm looking at my first term right here, and I'm asking myself, what factors can we use to give us 6x squared? Well, we actually have some options this time. I could multiply 6x times 1x. That would give us 6x squared. I could also multiply 3x times 2x. So I don't know which one of those I want to use yet, okay, but it's going to be one of those two options. So what I'm going to do now, I'm going to go ahead and look at this last term just to see what options I even have for that one. Well, the factors of 5 is a prime number, meaning it only has factors of 5 and 1. So this has to be 5 times 1. Since I don't have any other options there, I know I can go ahead and put a 5 and a 1 down here in my sets of parentheses. And again, you could switch them up, right? The 1 could go first, 5 could go second. It does not matter. Now I'm going to go over here and choose one of these two options to substitute in and see if it works. Okay, and again, it's trial and error. So if you try it and it doesn't work, then we'll try something different. I'm going to go with the 3x and the 2x first and just see what happens. So we'll go with 3x and 2x. Now, at this point, we need some signs. We need positives or negatives or one of each. If you look at your last term, we need to end up with a -5. That means the only way to get that is to multiply a positive value times a negative value. So I know one of these is going to be a plus and one of these is going to be a minus. I don't know which is which, okay? So I'm just going to choose and I'm going to try it and see if it works. If it does, great. If it doesn't, then I'll go back and try something different. I'm going to put the minus here. I'm going to put the plus here. All right, so now we're going to actually FOIL and see what we get. 3x times 2x is going to give us 6x squared. Outer terms, 3x times 1 is going to be a positive 3x. Inner terms, -5 times 2x is going to give us a negative 10x. And then finally, -5 times 1 is a -5. Okay, so my first and last terms definitely look good, the 6x squared and the -5. If I combine my like terms now, 3x minus 10x is actually going to be a -7x. So this gives us 6x squared minus 7x minus 5. That is not the same thing we started with. Okay, we needed to end up with a positive 7x. We got a -7x. If everything looks good except for the sign of your middle term, all you have to do is switch your positives and negatives. Okay, so that's the only thing that we have to change to make this one work. So I'm just going to come back up here and I'm going to say, well, let's make this the positive, make this the negative instead. Now let's FOIL and check it out. Okay, so my first and last terms are going to be the same. That hasn't changed. My outer terms here, though, we're going to get a -3x and a positive 10x. And so if I combine like terms, I get 6x squared plus 7x minus 5. That's exactly what we started with, so this checks out, and that tells me now that this is the correct factored form. And again, if you had tried 6x and x to begin with and you saw that it doesn't work, then you can go back and try the 3x and the 2x. So there will be some where there's several options. You're trying out a lot of different things. And that's why I said I would probably just kind of keep all of your work just to make sure that you're not accidentally trying the same thing multiple times. All right, so now we want to factor each of these expressions. So we have x squared minus 2x minus 3. Again, it's a trinomial. That tells me it's going to factor into two binomials. I'm going to start with my first term, the x squared. Only factors there are going to be x and x. So that tells me there has to be an x here and an x here. Now I'm going to look at that last term. We have a 3. Only factors of 3 are 3 and 1. So I know there has to be a 3 and there has to be a 1. And in this case, we need a -3, meaning that one of our signs has to be positive, one of them has to be negative. And in this case, I can look and see, well, I need a -2x. So the bigger value actually needs to be negative this time. So I'm going to go ahead and put my negative here and my positive here. And so the more of these you do, the more you'll start to kind of see some patterns and be able to recognize what things you probably want to try first just based off the numbers that you see there. Now again, we can check this. FOIL, x times x is x squared. Outer terms, x times 1 is plus x. Inner terms, -3 times x is a -3x. And then finally, the last terms, -3 times 1, -3. Combining your like terms in the middle here, x minus 3x is a negative 2x. That is exactly what we started with, so this is the correct factored form. All right, now, if we look at the second one, what I want you to notice is that really this thing is in exactly the same form as the previous one that we just did. The only difference is instead of just having an x, now we have this 5a plus 1 in place of our x values. So it's really going to factor exactly the same way as the one we just did. So if you can recognize this as being of the same form, we can just use those same factors, but instead of using x's now, those are going to become 5a plus 1s. Okay, so this is going to be 5a plus 1 minus 3. And then in place of the other x, we put a 5a plus 1, and then we have a plus 1. So again, all I'm doing is I'm taking the factored form that we got in the first part, I'm replacing that x, and I'm replacing that x right there with 5a plus 1. And now we can just combine like terms. And so this gives us 5a minus 2 and 5a plus 2. So this will be our factored form. Now, another option here, you could actually square 5a plus 1. You could distribute the negative 2 to the 5a plus 1. You could combine all of your like terms, and you could factor whatever you get. You're going to get the same answer. Okay, but again, this is much shorter than having to go through all those steps if you recognize that it's of the same form as the previous problem we just did. All right, now some special factoring formulas. So we've looked at special products, now we're working the other way. If you have a squared minus b squared, that's going to factor into a minus b times a plus b. Again, this thing right here is what we call a difference of squares. And the difference comes from the fact that it's a subtraction, and the squares is because they're both perfect squares, a squared and b squared. Now, if we end up with something like a squared plus 2ab plus b squared, that's going to factor into a plus b all squared. And that's basically the opposite of the special product formula we looked at before. So if you recognize that it's of that form, then we know it should factor into that. And the same thing with a squared minus 2ab plus b squared. Only difference now is we have the subtraction, so it's going to factor into a minus b all squared. And then these last two, and these are brand new, this is what we call a difference of cubes. Again, the word difference comes from the fact that there's subtraction, and the cubes is because it's a cubed and b cubed. Okay, but if you have something of that form, this is the formula we're going to follow every single time. And just know the a squared plus ab plus b squared part will never factor. Okay, so once you've actually got it to that point, we don't have to look for any more common factors, and that's as far as it's going to go. And then this last one here, instead of being a difference of cubes, now it's addition, so we call this a sum of cubes. Again, sum because it's addition, cubes because of the a cubed and b cubed. And again, we're going to get this factored form, and that second set of parentheses, once we get those values, it's never going to factor beyond that. Now, notice there is no such thing as a sum of squares, okay, in terms of factoring. If you have a sum of squares, it does not factor at all. You can't do anything with it. Okay, so we can only do differences of squares, but not sums of squares. All right, so now we want to factor this expression. So we got 4x squared minus 25. So notice we have subtraction. That makes it a difference. There's only two terms, which means you probably want to look to see, is it a difference of squares? And in this case, it is. 4x squared is a perfect square. 25 is also a perfect square. So I know when I go to factor this now, I'm thinking about my factors of 4x squared. but I want the two factors to be the same for my difference of squares. My only option then is going to be 2x times 2x. So I know I'm going to have a 2x here. I'm going to have a 2x here. Same thing with the 25. I need my factors of 25, but I need those two factors to be the same number. So my only option here is going to be 5 times 5. So we have a 5 and we have a 5. And remember, with the difference of squares, we need the middle terms to cancel out. So we need one to be positive, one to be negative. So this is going to be a plus and a minus. And again, if you want to check, by all means, please do that. 2x times 2x is going to give us 4x squared. Outer terms, 2x times negative 5 is negative 10x. Inner terms, 5 times 2x is positive 10x. 5 times negative 5, negative 25. And if we notice here, we have a negative 10x and a positive 10x. That gives us 0 in the middle. And so we are left with 4x squared minus 25. That checks out. And so this right here is our factored form. Now, if we look at the next one, this is also technically a difference of squares. And the reason is because we have x plus y squared. There's your perfect square. We have a difference because of the subtraction. And then we have z squared, which is also a perfect square. So when I factor this one, to get x plus y squared, I need to multiply an x plus y times an x plus y. I need those to be the same. So I'm going to have an x plus y here, and I'm going to have an x plus y over here. Now, because it's a difference of squares, we know one sign's positive, one sign's negative. So I'm going to get a plus here, minus here. And now we need the factors of z squared. That has to be z times z because they need to be the same factor. So I'm going to get a z here, and I'm going to get a z here. This right here is the factored form of what we started with. So again, even though there's two terms, the x plus y and that first perfect square, we can still use our difference of squares formula here and get that factored form. All right, so now we want to factor each of these trinomials. We're still going to use the trial and error method, okay, that we've been using throughout. So I'm looking at this and I say, well, I need two binomials. First term is x squared. That means I need an x times an x. That's the only thing that's going to give me x squared. So we put an x and an x. Now look at the last term, which is 9. My factors of 9 would be 9 times 1 or 3 times 3. And again, if you look at your middle term, the one that makes sense here is probably the 3 times 3, right? Because that might give us a 6. So I'm going to go with 3 and 3. Now we look at our signs. I either need two positives or two negatives to give us the positive 9. But because my middle term is a positive 6x, that tells me I'm going to go with positive values. So I'm going to do plus and plus. And if you FOIL this, you will see we get x times x is x squared. Outer terms and inner terms both give us 3x. Combining those gives us 6x. And then 3 times 3 is 9. So that looks good. Now, the other way we could write this answer, since we actually get the same thing in both sets of parentheses, is I could rewrite this as x plus 3 quantity squared. So whenever you have the same thing in both sets, you can actually rewrite that as a single set of parentheses raised to the second power. Okay. Now, if we do the same thing with the next one, again, I need two sets of parentheses. I'm going to start with my 4x squared here. So my options are 4x times x or 2x times 2x. And if we look at the last term, my only option there is going to be y times y. So I know for sure I'm going to have a y and a y. Now, because of the middle term, we need a negative 4xy. That tells me I'm probably going to go with 2x and 2x here, right? Because the 4x and 1x would either give us a 5 or a 3, depending on our signs. Okay, so I'm going to go with 2x and 2x. Now, again, we need to know our signs. Because I need a positive y squared, my only options are two positives or two negatives. And because I want the middle term to be negative, that tells me that I'm going to want two negatives this time. And again, I'm not going to take the time to actually FOIL that out and show you, but if you were to do that and combine like terms, it will give us what we started with. Again, notice this time we get the exact same thing in both sets of parentheses. So again, I could rewrite this as 2x minus y all squared. All right, now factoring differences and sums of cubes. So this is where we're going to use those formulas that we saw a couple slides ago. So we have 27x cubed minus 1. So in this case, we have the form a cubed minus b cubed. And so according to our formula now, that should give us a minus b times a squared plus ab plus b squared. And so now it's just a matter of finding the a and b values so that we can substitute into that formula. Well, the easiest way to do that is to say, well, I know my a cubed value is 27x cubed. So if I want to know what a is, I'm just going to take the cubed root of 27x cubed. Okay, so I'm taking the cubed root of both of these values. That's going to leave us with a here because the cube root of a cubed should just give us a. Cube root of 27 is 3 because 3 times 3 times 3 is 27. And the cube root of x cubed is just going to give us x. So now we know our a value is 3x. I can do the same thing with the b value. B cubed equals 1. Again, notice I'm just using a positive 1 because the formula takes care of the fact that there's a minus there. If I take the cube root of that, b is going to be equal to 1 because the cube root of 1 is still just 1 because 1 times 1 times 1 is still 1. Now I have all the values I need to plug into my formula over here. So we start with a minus b, so that's going to be 3x minus 1 times a squared, so that's 3x squared. Then we're going to have plus a times b, 3x times 1, plus b squared, 1 squared. Now we need to simplify what we have there. So we have 3x minus 1. 3x squared is going to give us 9x squared. 3x times 1 plus 3x. And 1 squared is just plus 1. And again, remember I said that second set of parentheses will never factor, so we don't even need to try it and worry about it. So this right here is the correct factored form of that difference of cubes. Now the next one, again, we have two perfect cubes here. Okay, so this is really a cubed plus b cubed. So again, our formula this time is going to be a plus b times a squared minus ab plus b squared. So again, I need to know the a and b values so I can substitute into our formula. So I'm going to let a cubed equal x to the 6th power. I'm going to take the cube root of that. So our a value in this case, remember, if you have something that's divisible, the exponent you can divide by the index. 6 divided by 3 is going to give us 2. So this becomes x squared. And then I'm going to let b cubed be equal to 8. Again, we're going to take the cube root so we can get our b value. So b equals 2 because 2 times 2 times 2 would give us 8. Now we follow our formula. So we have a plus b, so x squared plus 2, times a squared, that's going to be x squared squared, minus a times b, x squared times 2, plus b squared, 2 squared. Simplify what we've got there. We have x squared plus 2. X squared squared, we multiply the exponents. That gives us x to the 4th. X squared times 2 is going to be a negative 2x squared. And 2 squared should give us plus 4. Again, that second set of parentheses, never going to factor. Don't need to worry about it. So this right here is our final answer. All right, so now we want to factor each one of these completely. Okay, now the first thing we always want to look for is the first thing we look for when we first started doing factoring, and that's common factors. Okay, so anytime you have common factors, we always want to pull those out first. So if I look at both of my terms here, we have 2x to the 4th minus 8x squared. Looking at the numbers, the common factor is 2. Looking at the variables, we take the smaller of the exponents. That's going to be the x squared, so we can factor out an x squared. Now we go through each term and we figure out what's left over. If I factor out 2x squared from 2x to the 4th, 2 we already have. X to the 4th divided by x squared is going to give us x squared because we subtract those exponents. Then we have our minus. 8 divided by 2 is 4. And then x squared divided by x squared gives us a 1, so we have no x's left. So that's just x squared minus 4. Now, once you've taken out the common factor, we still want to look at what's left over and see if we can do anything else with it. Notice in this case, x squared minus 4 is actually a difference of squares, right? X squared is a perfect square, 4 is a perfect square, and we have the subtraction. So I'm going to keep the 2x squared. And now I can factor that difference of squares. Factors of x squared are x and x. Factors of 4 are 2 and 2. Remember, with a difference of squares, one needs to be positive, one needs to be negative, so we get a plus and a minus. Once we get it to that point, there are no other common factors, no other like terms to combine, so this right here is completely factored now. So next one, same thing, start by looking for common factors. So if I look here, I have x to the 5th and x. Of those, the smaller exponent is x to the 1st, so I can take out an x. Then between y squared and y to the 6th, the smaller exponent is y squared. I can take out a y squared. Now we look at what's left over. X to the 5th divided by x would leave us with x to the 4th. Y squared divided by y squared is 1, so there's no y's left at all. Minus x divided by x is 1, so we don't need any x's. Y to the 6th divided by y squared gives us y to the 4th. And so we're left with x to the 4th minus y to the 4th. Now again, we need to look and make sure that we can't do any more factoring or simplifying. X to the 4th minus y to the 4th is actually a difference of squares because it's a difference because of the subtraction. X to the 4th is actually a perfect square, and y to the 4th is also a perfect square. So I'm going to keep x, y squared. To get x to the 4th, I'm going to need an x squared and an x squared. Because remember, when you multiply, you would add those exponents together. 2 plus 2 would give us the 4. Now I'm going to look at y to the 4th. So that's going to give us y squared and y squared. And again, because it's a difference of squares, one needs to be positive, one needs to be negative. And again, it doesn't matter the order, so I'm going to put the minus first, plus second. Now, be very careful. Always look and make sure that you can't combine any more like terms and you can't factor any further. In this case, we actually end up with another difference of squares because we have x squared minus y squared as one of our factors. So we have to make sure that we continue and factor that even further. So I'm going to keep my x, y squared. Our next factor now is a difference of squares. So to get x squared, we have x times x. To get y squared, we have y times y. And because it's a difference of squares, one is negative, one is positive. And if we look at the last set of parentheses, x squared plus y squared, that is a sum of squares. We know we can't factor that, and so that's just going to stay x squared plus y squared. This now is the completely factored form of that polynomial that we started with. So again, always start with common factors, bring those out first, look at what's left over, see if it factors any further. But again, be very careful. Don't just assume that one more step is going to be good. Sometimes you are going to have other factors remaining that you can still factor even further. All right, now I'm only going to do the first one of these, okay, because I'm never going to give you anything like the second one. Okay, but if we look at this one now, again, the first step is always to look for common factors. So I'm looking at my numbers first. We have a 3, a 9, and a 6. Of those, the common factor would be 3 because 3 goes into all of those numbers. So I'm going to take out a 3. Now I look at my variable, and remember, we're always taking out the smallest exponent of all of those variables. So I know it's going to be x to some power of 3 halves, 1 half, and negative 1 half. The smallest value is negative 1 half. So we're actually taking out the x to the negative 1 half because that is the smallest of all of your exponents. Now we figure out what's left over. Well, again, I'm basically taking each of my terms and dividing out the 3x to the negative 1 half. So we have 3x to the 3 halves. I'm dividing that by 3x to the negative 1 half. 3 divided by 3 is 1, so those numbers cancel out. X to the 3 halves divided by x to the negative 1 half. Remember, when we divide, we subtract exponents. So we're taking 3 halves minus a negative 1 half. If I do that, subtracting a negative actually turns into addition. So this actually gives us 4 over 2, which simplifies to 2. So we're left with x to the second power. So that first term now is just going to be x squared. Now we're going to do the same thing with the next term. We have a negative 9x to the 1 half. I'm dividing out 3x to the negative 1 half. Well, negative 9 divided by 3 is going to give us a negative 3. And now when I divide the x to the 1 half by x to the negative 1 half, remember we're going to subtract exponents. So we have 1 half minus negative 1 half. Again, that becomes addition. So that gives us 2 over 2, which simplifies to 1. So my exponent of my x should be 1. So it's just going to be x to the first power. So my second term is negative 3x. And then finally, we take the 6x to the negative 1 half. We're dividing out the 3x to the negative 1 half. 6 divided by 3 is 2. And notice here we have an x to the negative 1 half divided by x to the negative 1 half. Because those are the same, they're going to cancel out. If you do the subtraction, it still works. Negative 1 half minus a negative 1 half is actually going to give us 0 because we're adding negative 1 half plus 1 half. And so we have no x left over at all. And so this is just a plus 2 now. All right, now, again, once we factor out our common factor, we always want to look and see, is there anything else we can do to factor this further or simplify it? Well, I end up with a trinomial that might be able to be factored. Okay, so I'm going to try it. We're going to have 3x to the negative 1 half. And now I'm going to look for factors that might give us that trinomial. My options here are x and x to give us x squared. So I'm going to go ahead and put an x and an x. If we look at the 2, only factors there are 2 and 1. So I'm going to go with a 2 and a 1. And then the signs have to be the same to give us a positive 2. So we know it's either going to be negative, negative, or positive, positive. In this case, the middle term is a negative 3x. That tells me I'm going with negatives. I'm going to go negative, negative. And if you were to FOIL that out, you would see that you get a negative 1x and a negative 2x. Combining those gives us the negative 3x in the middle. And so this right here is the correct factored form. Again, the key to this one is always factor out whatever the smallest exponent is. So that x to the negative 1/2 is your smallest exponent. Once you've done that, then we can look at what's left over and factor it further if possible. All right, in our last example here, now we're going to look at factoring by grouping. So if you ever have 4 terms and you don't have any common terms that you can combine, what we're going to want to do here is actually group pairs of terms together and look for common factors. So in this case, I'm going to group my first 2 terms together, and then I'm going to group my second 2 terms together. And now inside of each set of parentheses, I'm going to look for common factors. So between x cubed and x squared, the common factor is x squared because that's the smallest exponent of those 2 terms. So I know I can take out an x squared. Then if we look at what's left over, x cubed divided by x squared leaves us with an x. X squared divided by x squared leaves us with a 1. Notice we need that 1 to hold the place of that x squared. Okay, so there's going to be a +1 there. Now we go to our other set of parentheses. Again, we're looking at common factors. Between 4x and 4, the only thing they have in common is the 4. So I'm going to bring out a +4. And if we look at what's left over from the first term, we're left with an x. And again, 4 divided by 4 is 1. So again, I need a +1 to hold the place of that 4. Now, looking at what we have here, this is similar to another example we had where we have a common factor that is 2 terms. So we have an x + 1 in both, which means I can actually take out that common factor of x + 1, and then we just need to think about what's left over. Well, if I take out x + 1 from this first one, I'm left with the x squared. And if we take out the x + 1 from the second piece, that leaves us with a +4. So whenever you're doing grouping, we're basically grouping 2 terms together, factoring out what they have in common, and then looking to see, does that create any common factors, like the x + 1 here, that we can then bring to the front. Now again, always look to see, can we factor any further? In this case, x squared + 4 is a sum of squares. That does not factor any further, and so this would be our final answer. And again, the last one here, 4 terms, no like terms to combine, so we want to group. So I'm going to group my first 2 terms together. I'm going to group these other 2 terms together. Notice I kept the negative with the 9x, and I'm going to put a little plus here just to remind us we're really adding all these terms together. I just want to make sure that the negative goes with the 9. All right, so now if we look at the first set, between x cubed and negative 2x squared, the only thing they have in common is x to the 2nd power. So I'm going to factor out x squared. X cubed divided by x squared leaves us with x. Negative 2x squared divided by x squared gives us a -2. Now if we look at the negative 9x and the positive 18, the only thing they have in common is a 9. Now I could either take out a +9 or a -9. In this case, because I'm trying to match this factor of x - 2, that tells me that I'm going to want to take out the negative so that I end up with a positive x there. So I'm going to factor out a -9, which would leave us with a positive x, and then a -2. Now we have the same factor of x - 2 in both of those pieces, which means I can bring that to the front as my common factor. And what's left over is the x squared and the -9. Now again, always look to see, is there anything else in common? Or is there anything else I can do to factor? Well, x - 2 is good, but x squared - 9 is a difference of squares. So we need to factor that further. So I'm going to bring down the x - 2. And then I'm going to factor my difference of squares into two binomials. Factors of x squared, x and x. Factors of 9 to give us the perfect square is going to be 3 and 3. And again, with a difference of squares, one's negative, one's positive. So we're going to have a minus and a plus. And so now this is completely factored, and that is our answer. All right, so that's all we have for section 1.3. Again, if you have any questions in the WebAssign homework, please send me those questions. Let me know if you want to meet for office hours, and I'll be happy to do that. Otherwise, have a great day, and I will see you next time.